Good morning. Welcome back. Last class, we completed the lab programs and we started with a new chapter, Boolean Algebra. Boolean Algebra does not have any programs or any algorithms. We'll be like, it's purely, we are talking about logical multiplication, addition, and then the logic gates and evaluation of expressions using writing proofs for expressions using truth table, or you can do it algebraically or through induction method, and then finding solutions of expressions and different types like SOP, that is sum of product and product of sum expressions. All this we would be doing, and this is a 9-mark chapter. So please pay attention, it is very interesting also. And when you're doing it, keep a book and a pen so that you can solve it along with me and you can write it down. So it's not something wherein you will sit and mug. It is better you understand. Once you understand, you don't have to mug because the properties do not change. So we started yesterday, we did this evaluation of an expression using truth table, like what are the three basic gates I did, or, and not, and we wrote the truth table for that, and then we did evaluation of expressions using the truth table, how to construct a truth table. Depending on the number of variables, the truth table will have 2 raised to the number of variables. So that many rows will be there in that, and then x and x bar is nothing but if x is 0, x bar is 1, is just the complement of that. And we also did that a variable can have only 2 values, that is 0 and 1. Since it is Boolean, it is either 0 or 1. And during the class, I could see many of them had confusion between arithmetic, like binary arithmetic, and logical arithmetic. Like logical means it depends on the truth table. The number of high and low will decide the output, whereas binary, yes, you do have carry, borrow and all that. It's just like you're doing the normal arithmetic, but only thing is the numbers would be in base 2 rather than what you do in base 10, but the rules and everything would be same. But if it's a base 10 number, you do it the same way you will do for a base 2 number. The same number can be represented in base 2 system, that's all. But whereas here it is number of high or low, or I can say true or false, high or low, whatever. High is 1, low is 0, and then or true is 1 and false is 0, depending on the logic gate is something which will take inputs more than 2 or more inputs. It cannot get takes only 1, whereas other gets 2 or more inputs and it will give you only 1 output. And I wrote you the truth table for that also. After that, we did the evaluation of 2 variable and 3 variable one. Now we will start with Boolean postulates and theorems. So what is a postulate? The fundamental conditions or self-evident propositions. It's the fundamental conditions or self-evident propositions are called postulates. That is, postulates of Boolean algebra originate from 3 basic logic functions and, or, and not. Okay, what are the 3 basic logic functions? They are and, not, and or. So they are also basic gates also, or and, not, and or gates. So basic Boolean algebra originate, that is the postulates of Boolean algebra originates from the 3 basic logic functions and, or, and not. The properties of these 3 basic functions are given here. You can see here the properties of these is given here on the slide. You can see it here, and these are called Boolean postulates. Okay, these are called Boolean postulates. The properties of the 3 basic logical functions are given over here. You can see or functions, or and complement rules, or I can say not. This is a not gate, this is an or, and this is a and. And these are called Boolean postulates. What are Boolean postulates? The properties of this. That is, whatever is written here is called Boolean postulates. The postulates define the operation of the and, or, and not functions. Okay. In other words, I can say that these are the results of these basic operations. Fine. Now we will start with each one. Okay, an or relation. This one is the symbol of or. Whenever they ask you, please don't change the symbol. The symbol should be written this way only. You cannot define or change that symbol for any reason, and it has to be written so that it's normally asked as a one marker. And please don't, if you leave this bubble, this is nothing but the inverter. If you leave that, you won't get 1 mark also. So what are the two values x can have? X can have either 0 or 1, only two values, right? So if x is not 0, then it should be 1. If it is not 1, then it should be 0. It will have only two states, that is high or low. It can be on or it can be off. When I say on and off, 0 is off, on is 1, like high and low, or 0 and 1. So if x is not equal to 0, then x is 1. If x is not equal to 1, then x is 0. Fine. This symbol, we can use this symbol in system, we use this. Or since we are not doing it on system, you can use equal to and a slash, or not equal to an exclamatory mark, and equal to can also be used for not equal to symbol to say that it is not equal to. We'll start with logical addition. Please note it down, logical addition. I'm not talking about arithmetic addition here. I'm talking binary addition. I'm not talking here. I'm talking about logical addition. Binary addition is wherein you will be adding and there will be carry, all that would be there. 1 plus 1 is 1 0 over here, over there. If you are doing binary addition, right? 1 plus 1 is 2, nothing but 1 0 in binary, whereas here it is 1 plus 1 would be 1. When both are true, it is true. Getting it? So don't get confused over here. What I'm doing is, here the first input is 0 to an OR, second input is also 0. So the result, because two or more inputs and it will have only one output, that is what it shows over here, and it is 0. That is 0 plus 0 is equal to 0. This is logical addition. And then whenever they ask you, you need to write all this, draw all this. Suppose if one input is 0, the other is 1. For a logical addition or an OR, it will be 1. Getting it? If one input is 0, the other input is 1, it will be 1. That is 0 plus 1 is equal to 1. And the next one I can see here is, if the first input is 1, the second is 0, and that is 1 plus 0 is also 1. The output would be high or true. And then if both the inputs are true, then also the output would be true. That is 1 plus 1. In binary arithmetic, binary addition, what will you do? You will write 1 0. But here I am doing logical addition. When I say logical addition, 1 plus 1, that is 1 or 1 is equal to 1. Both the inputs are high, the output is also high. Please make a note of this. Boolean postulates. The next, please make a note. The next is logical multiplication. It is always and. And is logical multiplication, or is logical addition. Complement is not. So 0, see, this is the symbol of and. You need to write this symbol only. So what does it take? It can take 2 or more. Here I have 2 inputs and it will give me 1 output. If both the inputs are low, that is 0, false, the output is false. It is 0 dot 0. Multiplication, logical multiplication, dot, or 0 and 0, or 0 dot 0 is equal to 0, And then the next one is if one input is 0, the other one is 1, the output is 0. That is 0 dot 1 is 0. The same thing 1 dot 0 is also equal to 0. For an AND, both should be true. That is, both the inputs should be true to get a true output. Otherwise, if one of that is false also, the output would be false. Yeah? Please make a note of this also. Then we have complement rules. That is bar. This is called a bar. 0 bar is equal to 1 or 0 right? 0 bar is equal to 1. So if I input a false to that, the output would be true. This bubble is the inverter bubble. So then if I enter 1, if I give 1 as or a true as an input, the output would be false. It will just complement the input. If it is true, it becomes false. If it is false, it becomes true. That is 1, 0, 0, 1. And this is the symbol. Any one of this can be asked for 1 mark. Please make sure you write the symbols properly. The shape should be proper. You cannot, and whenever they ask, you need to write the input and then the output also. Please make a note. So, we are done with Boolean postulates. Now, we will go to properties of 0 and 1, which is important. So, when this we will use when you are actually evaluating an expression. So, the important properties of 0 and 1. First property is 0 plus x is equal to 1. Equal to x. So, 0 plus x is equal to x. You are using logical OR here. That is logical addition. I am doing logical addition over here, or you are using OR here. That is 0 plus x is equal to x. So, when you are writing the proof, because x can take only two values, it can either be 0 or it can be 1. So, you need to write proof for both. That is, when x is 0 also, it should satisfy the condition, and when x is 1 also, you should get LHS is equal to RHS. First thing I will take, if x is equal to 0. If x is equal to 0, LHS. What is LHS? 0 plus x. If x is equal to 0, 0 plus x, in the place of x, substitute 0 because I say x is equal to 0. So 0 plus 0, according to the truth table, when both the inputs are false, or gives you a false value, right? We have already seen that. According to the truth table, when or will give you false only when both the inputs are false. Otherwise, if at least one of them is true also, you get a true value in case of a OR. So, here 0 plus 0 in OR is like both are false. So, you get the result false. It is equal to 0, which is equal to RHS. What is RHS? X here. So, what is the value of x I have substituted? I have substituted 0 over here. So, 0 plus x is equal to x. When x is 0, you get LHS is equal to 0, which is nothing but RHS. And then when x is equal to 1, you need to prove when x is equal to 1, because you need, whenever you are writing the proof, you need to write for both x is equal to 0 as well as x is equal to 1. If x is equal to 1, LHS is equal to 0 plus x. What is x? 1. So, substitute 1 in the place of x. So, you will say 0 plus 1 in OR. If one of the inputs is high, the output is high according to the truth table. We have written the truth table in the last class. So, 0 plus 1 is nothing but true, 1. So is equal to RHS. What is RHS? X. And what I have taken the value of X? I have taken it as 1. So 1 is equal to 1. Hence the proof for both the values, your RHS is equal to LHS is equal to RHS when you substitute that value. So you say 0 plus X is nothing but X. Truth table. What are the two things here? 0. It's not a variable over here. It's a constant, right? 0 cannot be a variable. 0 is 0 only. You cannot change 0 to something else. But X is a variable wherein X can take how many values? It can take 2 values. So, it is like number of variables is 2. So, you have 2 rows. That is 2 raised to 1 because only one variable is there over here. That is 2. So, 0 and 1. What are the values of X? 0 and 1. 0 remains 0 as it is because 0 is not a variable. It will not take the value of 1 anytime. 0 is not equal to 1 at any point of time. So, X can be 1 or X can be 0. So, I will say 0 and 0 and 0 and 0. X is 0, X is 1. These are the only two possible values. So, 0 plus 0 is 0. That is 0 plus X and it is 1. So, you are getting here 0 plus X is equal to X. Can I see here? See, these two columns are same. So, 0 plus X is equal to X. According to the truth table also, we have proved the property, and this is how I write it. This is 0, this is X and this is X. So whatever is the value of X would be here. If X is 0, the output would be 0. If X is 1, the output would be 1. Hopefully you've understood this one. The next property is 1 plus X is equal to 1, because you need to remember all this whenever you are algebraically deducing an equation to its simplest form. Wherever you get 1 plus X, it need not be X only, it can be anything because it's a variable, right? It can be Y, Z or whatever, should be substituted with 1. Whenever you get that term, you normally substitute it. 1 plus X is equal to 1. So instead of that term, you can substitute it into as 1. So you need to remember all this. So 1 plus X is equal to 1. The proof here, I have only one variable, that is X. So if X is equal to 0, what will I do? LHS is equal to 1 plus 0. What is 1 plus 0? It is 1. I am doing logical addition over here. So 1 plus 0, that is at least one of that is high also, the output would be high. So 1 plus 0 is 1 plus 0 is 1, which is equal to RHS. Yeah. And the next one is if X is equal to 1. What is the proof here? LHS is equal to 1 plus X. So 1 plus 1, it is not 1 0 because I am not doing binary addition here. I am doing logical addition. Whenever you do logical addition, you are not literally adding it. You are just taking the two inputs are high. So the output should be high. So 1 plus 1 is 1 in logical addition. So it is equal to RHS. Yeah. So the next one is 0 dot x is equal to 0. What operation are we doing here? We are doing logical multiplication. That is the AND operation over here. Plus is or, dot is and. Please don't get confused with that. So this is logical multiplication. 0 dot x is equal to 0. The proof is X is equal to, again, whenever you are writing proof, then you need to write for both the values of X. If X is equal to 0, that is 0 dot X, which is equal to 0 dot 0. According to the truth table, 0 dot 0, that is when both the inputs are low or false, the output is false, which is equal to 0, that is RHS, correct? Then if X is equal to 1, so LHS is equal to 0 dot X. What is the value of x? X is 1. So 0 dot 1. Again, according to the truth table of AND, both the input should be high to get a high value, or both the input should be true to get a true value. So 0 dot 1 again is 0, because 1 is 0 means the entire thing. Both should be true, then only you will get the output as true, otherwise it will be false. So 0 dot 1 is equal to 0 again, which is RHS. So truth table, how many rows? 2 raised to number of variables. How many variables are there? 1, which is x. So 2 raised to 1 is 2. So there are 2 rows over here. One is 0, the other one is x. 0 is 0 only. 0 doesn't take any values. X can take 0 and 1. So 0 dot 0 is again 0. 0 dot 1 is again 0. You can see this is the LHS, this is the RHS, both the columns. This is 0 dot x is equal to 0. So this one and this one, the first column and the last column, because 0 dot x is equal to 0. So this is the column for the RHS, this is the column for the LHS. So both are same. And this is the logical circuit. That is, one input is 0, means whatever is the value of x, the output would be 0. X can be 1 or 0, it doesn't matter. Once you have 0 dot x, when you are doing a dot operation or the multiplication, logical multiplication, the output would be 0. The next one is 1 dot x is equal to x. Whatever is the value, 1 dot x, whatever is the value of x, that would be the output. So what is the proof here? X is equal to 0. What happens? LHS is equal to 1 dot 0. So what is the value of 1 dot 0? It is 0, because one of the inputs is false, so it becomes 0. So which is equal to 0, which is equal to RHS. What is RHS? RHS is x. What is the value of x here? X is 0, which is nothing but the RHS. The second one is x is equal to 1. If x is equal to 1, then LHS is equal to 1 dot x. So what is x here? X is 1 over here, then 1 dot 1. So what is 1 dot 1? Because both the inputs are high or both the inputs are true, the output is true, that is equal to 1. What is 1? 1 is nothing but x, because I have taken the value x is equal to 1. It is the RHS, hence the proof. In truth table, you can have a look. 1 is 1, 1. X can be 0 or 1. And 1 dot 0 is nothing but 1 dot x is 0. 1 dot 1 is again 1. So 1 dot x is equal to x. You can see these two columns are same in the truth table, and this is the circuit. Like 1 is one input, x is the other, wherein x can be either 0 or 1, and whatever is the value of x would be the output. Please make a note of this. This is very important. The next is Principle of Duality. They will ask you to find the duals of a certain. They will give you one Boolean expression and they will ask you to write the dual of it. I will write it and I will show you how to do it. We'll solve some more extra also apart from whatever is there in the slide. The question would be, write the principles of duality, and that is one question, or they can give you one Boolean expression and then they can ask you to find the dual of that. The first one is changing OR sign to an AND sign. So whatever Boolean expression they give you, wherever OR, that is the plus symbol is there, change it to AND, that is dot. When you're finding the dual of a Boolean expression, the first thing what you need to do is change OR, that is plus, to AND, that is dot. The second one is changing and to or. So when you are writing, write it in four three different statements, or write it as a four different statements. Each statement would carry half mark. Don't write it as changing or to and to or. It makes sense, but then when you're writing in your exam, write it explicitly in a separate steps. So changing or, that is plus, to and, that is dot, that is the first step. Second one is changing and, that is the dot, to or. Fine. So in the Boolean expression, wherever plus is there, change it to and, that is dot, and wherever dot is given, change it to plus. After that, replace 0 by 1. If there are zeros in the expression, replace it by 1 and replace 1 by 0. So after doing all these four steps, you will get the dual of a Boolean expression. This is the theorem of duality theorem. Please note down these four steps. Then we will do this, how exactly we got this, and I will do some more apart from this. Please first make a note, that is changing or to and to or, 0 by 1 and 1 by 0. So you can write down this. This is very important. They will ask you, and it is very easy also. Find the duals for the following Boolean expressions. So the first one, what I have to do, that is, what are the first one, let it be, the question is x plus 0 is equal to x. I need to find the dual of the following expression. What are the four rules? That is change or to and to or, 0 to 1 and 1 to 0. These are the four things which you need to do to find the dual of a Boolean expression, right? So, how will I do that? Here, x remains as it is. I am not changing x here. You are changing only zeros and ones. The variables remain as it is. You are not going to touch the variables over here. Next, x remains as it is. What is the next thing? Is symbol plus. So, what I am going to change? I am going to change it to dot. And then, what is the other one? 0 to 1 I need to change. So 0 is here, I will change it to 1 is equal to x, because x remains as it is, equal to also remains as it is, because I am not changing equal to also to anything. So the dual of x plus 0 is equal to x is x dot 1 is equal to x. We know it is true also, right? Definitely, because we proved it, 0 and 1 property. When we did that, we proved that x dot 1 is equal to x. They can give you like this. The second one, find the dual of x plus 1 is equal to 1. So I need to find the dual of this Boolean expression. So what will happen? X remains as it is, because according to the four laws, you are only changing and to or to and, 0 to 1 and 1 to 0. You are not talking about whether it's x, y, z, whatever variable are there. I'm not going to touch the variables. So x remains as it is. Addition will logical addition will be logical multiplication, that is plus to dot, that is or to and 1 to 0 is equal to 0, right? We need to do that because x dot 0 is equal to 0. Yes, that is also true. Next is x dot x dash. X dash is nothing but x bar is equal to 0. So x dot x dash is equal to 0. Can I prove this? Yes, for example, if x is 1, what is x dash? It will be 0. So 1 dot, when if x is equal to 1, then 1 dot 0. What is 1 dot 0? It is 0. If x is equal to 0, then x dash will be 1. So it will be 0 dot 1. Again is equal to 0. So it's a proper statement. You don't have to prove, but then I'm telling you this. How do I find the dual? X remains as it is. Dot would be changed to plus x dash, or x bar remains as it is equal to, I need to change 0 to 1. X plus x bar is equal to 1. Can I prove that? Yes. If x is equal to 1, then 1 plus 0 is 1. If x is equal to 0, it is 0 plus 1 is equal to 1. Correct? Because or one of that is true also, the entire thing becomes true. So this is the dual of the expression. Next is fourth one. X plus x bar, x plus x bar is equal to 1. Okay. So I need to find the dual of it. X remains as it is. Plus becomes dot. X bar remains as it is equal to 1 becomes 0. Yes, it is correct over here also, right? The dual of this, because in the dual you need to change all or symbols to and to or, 1 to 0, 0 to 1. You're not doing anything to the variables present in the Boolean expression. Next is the fifth one. Fifth one is x plus y dot x bar plus z bar dot y plus z. Y plus z. You need to find the dual of this. So how do I do that? So all that dot should be changing to dot. So it will be x dot y, correct? And all that dot or and to or. So I need to change this over here. And again plus 2, x dash remains as it is, plus 2 dot z dash remains as it is, because I am not doing over anything over here, because I am not touching the variables. Then I do have, sorry, this is x dash, right? Yeah. After that, I will have, instead of dot, I need to substitute it with plus, and then y dot z. This is the dual of the expression xy plus x bar z bar plus yz. The dual of x plus y into x bar plus z bar into y plus z. The dual of that is x dot y plus x bar dot z bar plus yz. Hopefully I've got this. Next is sixth. Find the dual of x dot y plus z. Okay, x dot y plus z. What is the dual of that? X remains as it is. The dot has to be converted, like you need to and to or. So I will use plus over here, and y plus z would be y dot z, right? It should be x plus y dot z. This is the dual of this. The next one is x plus x dot y is equal to x plus y. So how will I do that? What will I do here? I will say x remains as it is. Instead of plus, I need to write dot over there, and then this one, what it will become? It will become x plus y, right? Is equal to x dot y. Yeah, this is the dual. So just I want you to write it down because this concept is important and it is very easy. It's a commonly asked, like I can say 90% asked question. Very few times this question will be not there. Either they will ask you the duality theorem, like principles of duality theorems, wherein you need to write the four principles, that is change all, or to and, that is plus to dot, change all or to and to or, that is dot to plus, change all zeros to ones, and change all ones to 0. This one they will ask, or they will ask you, they'll give you two boolean expressions and they will ask you to find the dual of that, and it is very easy. So I want you to write it down and do it. I'll just give you 2 minutes. Please copy it down. So you have, hopefully we did that, and now I think we didn't do this fourth one. I think we did that. Fifth one we'll have to do. X plus x dot y is equal to x plus y. So x is written as it is, plus is changed to dot, x dot y is changed to x plus y, because I am changing this dot to plus is equal to x plus y. So I am writing the variable as it is x, and dot, the plus is changed to dot over here, and then you need to write the y. So the principle of duality is nothing but what you have to do, you have to change all the or to and to or, 0 by 1 and 1 by 0. Please copy this down. The last two I believe you need to do that. Remaining we have done. The next, again, you need to know all these theorems, because when we are algebraically solving any Boolean expression, you would need all these laws. So based on this, you would be reducing, right? And these are all 1 mark questions. They can ask you what is involution law or idempotent law, anything, associative law. When they ask you associative or distributive, you need to write that for both addition as well as multiplication, both in statement as well as in uh, expression kind. Fine. The first one is identity law. What does it say? Law or theorem, I can say x plus 0 is equal to x and that is the law of addition. That is, identity law of addition states that when a variable is ORed with 0, then the result would be the variable itself. When a variable is ORed with 0, then the result would be the variable itself. The law of multiplication is x dot 1 is equal to x. So when a variable is and and with 1, then the result would be the variable itself. So whenever I say x plus 0, you need to directly substitute with x. Wherever you find x dot 1, it gets substituted by x, and then you need to write the law also, like what according to which law you are substituting it or changing it, right? The next one is the complementary law. So what does it say? It is complementary law over here, or complementary theorem, or complementary law of addition. What does it say? It says that this law states that when a variable is and with its complement, when you write and, you write a and d in capital and put a apostrophe and ed you need to write in lowercase. A and d, that is and, means you're doing that operation. So a and d in capital, put an apostrophe and then ed in lowercase. So this variable, what is the complementary law states? This law states that when a variable is and with its complement, that is, complement is nothing but the like x bar, x dash, whatever is there, like with its complement is equal to 0. Yeah, I can say is equal to 0, and a variable is ORed also, you will be writing OR in capital with an apostrophe and ED in lowercase, and a variable is ORed with its component, it is equal to 1. So the complementary law states that when a variable is ORed means plus, right, with its complement, and complement is x dash. So if x is 1, it will be 0, just the inverse of that. So when a variable is ORed with its complement, the result is equal to 1. Yes, I can see over here x plus x bar is equal to 1. The same way, when a variable is and, a and d in capital, ed with an apostrophe ed, when a variable is and with its complement, that is x bar, or I can say x bar dot x also, right? When a variable is and with its complement, the result is 0. This is complementary law of addition and law of multiplication. Next is idempotent law. So what does that law states? You have idempotent law of addition as well as multiplication. This law states that when a variable is and with itself or ORed with itself, it is equal to the same variable. You need to write the statements also. The idempotent law states that when a variable is and, so I'm doing it and dot with itself. Yes, I'm doing x dot x. So it is getting and with itself, or the variable is ORed with itself, x plus x. The result is the variable itself, that is the same variable. I will say x plus x is equal to x dot x is equal to x. These one we repeatedly you will use this, because you can reduce it to one term. X plus x, instead of that 2 you can directly write 1x, or x dot x will not be x square, it is x only. So please don't make this mistake over here. X dot x is x, not x square, or x plus x is not 2x, it is x plus x. When a variable is ORed with itself, this is a very important law, please mark it, wherein we'll be repeatedly using it, and this is one marker repeatedly asked question. The idempotent or the involution, they normally ask these two, and while deducing we'll use distributive law of addition or multiplication is repeatedly asked. I mean, we'll be making use of that. So when a variable is ORed with itself, the result would be the variable itself, and when the variable is AND with itself, the result would be the variable itself. Next is dominant law. When the variable is AND with 1, the result is 1. When a variable is ORed with 0, when the variable is ORed with 1, the result is 1. When a variable is AND with 0, the result is 0. So, this is dominant law. Next is involution law. See, I can see here it is x double bar. X bar, double bar is x only, because double bar you remove that. 2 bars will go. X double bar. Suppose if x is 1, what happens? X bar will be 0. Again, bar of 0 is 1. So, x double bar is x itself. The statement is, this law states that when a variable is inverted twice is equal to the original term. The involution law states that when a variable is inverted twice, when a variable is inverted twice, it is equal to the original term. So, x double bar is equal to x. If x is 1 or x is 0, x is 0, single bar is 1, again one more bar is 0. So, which is the original term itself. When the involution law states that when a variable is inverted twice, it is equal to the original term. Next is commutative law of addition. X plus y is equal to y plus x. Commutative law of multiplication. X dot y is equal to y dot x. The commutative law states that the order in which two variables are ORed or and make no difference. That is what it says. That is the commutative law. What does it state? The order in which two variables are ORed, whether you write it as x plus y or y plus x, both are same. Like if I write it as x plus y, that is x plus y is equal to y plus x, or and that is x dot y is equal to y dot x. That is, the commutative law states that the order in which two variables are or this is or normal English and or and does not make any difference. That is what the commutative law states. That is, whether you or it or and it doesn't make any difference. Getting it? Hopefully you're writing it down along with me. Please do that. This laws, I want you to make a note of all that. Next is associative law. Associative law it was. What is associative law? You have associative law of addition as well as multiplication. Associative law allows the removal of brackets. Associative law, what does it do? Removal of brackets from an expression and regrouping of the variables. The associative law allows the removal of brackets from an expression and regrouping of the variables. Am I removing the brackets? Yes. X plus y plus z is equal to, I have made x plus y. I changed the bracket, regrouping I did. First the group was between y plus z, and then x plus y plus z is equal to x plus y plus z. It doesn't make any difference. And the other one is x dot y dot z, that is grouping is this way, is equal to x dot y dot z. That is the associative law of multiplication, and this is the associative law of addition. Right? The next is distributive law. What does the distributive law, when they ask you, you need to write for both addition as well as multiplication. The distributive law allows the multiplying or factoring out of expression, right? It allows the multiplying or factoring out of an expression. So I can say x dot y plus z is equal to x dot y plus x dot z. Please mark it as very important, because every expression I will be using, like SOP, POS, we will be using distributive law. So you should know distributive law properly, like x dot y plus z is equal to x dot y plus x dot z. This is for addition, and x plus yz is nothing but x plus y into x plus z. This multiplication and addition, you use it repeatedly. So you should know, because every time I will not be telling you according to the distributive law. So you should know both addition as well as multiplication. X dot y plus z is nothing but x dot y plus x dot z. The other one is x plus yz is equal to x plus y into x plus z. Next is absorption law, like De Morgan's I will tell you, but the next one is absorption law. The absorption law enables a reduction of complicated expression to a simpler one by absorbing common term. So what is the common term over here? The common term is, x plus x dot y is equal to x, and other one is x dot x plus y is equal to x. We can that proof, yes, we can do that. X, if I take the first one, x plus xy is equal to x, take out common x, so it will be x into 1 plus y. So what is 1 plus y? 1 plus y is equal to 1 according to dominant law. So x into 1, which is x dot 1 is 1 according to identity law. Sorry, x dot 1 is equal to x according to identity law. So I will get x is equal to x. The same way I can do for the other one. Proof, I will do it in detail for each of these laws. We will do proof. But hopefully you've understood this. Today's homework is write and learn the principles of duality and Boolean theorems. I want you to write statements for each of the Boolean theorems. Please make a note of this. So, take care, stay safe. See you on Monday. Bye-bye.